Welcome to the Clean Titans channel, where we dive deep into the minds of clean titans working to clean our future. Today, we're glad to have Derek Dorresteyn. Derek, please introduce yourself and tell us a little about your background.
Hi, I'm Derek Dorresteyn. I've had a really interesting career that started off in product design and manufacturing, and for the last 15 years has been focused on electric motorcycles. First founding Alta Motors in 2010 with a couple other San Franciscans, and more recently with Damon Motors from Vancouver.
Derek, what sparked your initial fascination with electric vehicles? Was there a specific moment or experience that set you on this path?
Yeah, there were several. I had this interesting anecdote from being a young man racing Speedway, racing professionally racing Speedway. And my father, who had been around motorcycle racing his entire life, he had something he would say that when you tune a motorcycle perfectly for going around a dirt oval, it would behave like an electric motor. And what he really meant was it would have very linear torque. And we struggled in the development of racing engines at that time to build things that had linear torque. They would either be very peaky or they would not quite have enough power. And when you make a peaky bike, it's more difficult to ride, and so the results are a little less consistent. So we were striving for that electric feel back then. This is back in the 80s, and so fast forward a few years. I'm established in my career, and I'm working for tech companies indirectly as a supplier and a contractor. And I'm reading Martin Eberhard on the Tesla blog, and Martin Eberhard is talking about that finally this missing link to make electric vehicles has been created, and that is the ubiquitous cylindrical battery cells that have been put into laptops at the time. They were made in the billions at that time, and they were made and continue to be made at very low cost. And Martin had figured out that the rest of the vehicle was sufficient. And now with these lower cost batteries that had good capacity, these early lithium ion batteries, it was possible to make an electric car. Well, I'm a motorcycle guy, and so I immediately started thinking that if it's possible to make an electric car, it's probably possible to make an electric motorcycle. And that started me down that path.
Looking at your career, you have transitioned from hands on engineering to a more visionary leadership role. How has that shift influenced your perspective on innovation?
Well, it's been clear all along that innovation requires a team. You can't be a deep technical expert in every single thing. And I've always tried to surround myself, frankly, with people that are smarter than me. And that's the key to building great innovative products. You find those technical experts and minded people who are willing to put in the hours and stretch their own knowledge, their own comfort to build something new and innovative.
Absolutely, takes a team. Many people have an idea of what the future of EVs will look like. What is the common misconception that people have about the future of EVs?
Well, it's hard to say what people are thinking today, right? We've had a political reversal in the United States where suddenly it's not as popular to talk about a future where the majority of transportation is electrified. I still believe in that future. I still believe that we need to change our ways and burn less fossil fuels and have less of a carbon footprint as individuals on this planet. And I believe that transportation is a ripe category to do that. I don't know what people are getting wrong. I know that it's happens a little bit slower in some categories than others. For instance, heavy transportation like trucks are a much different kind of challenge than making passenger cars, and motorcycles in the same vein don't really travel very far each day, and many trucks by definition travel great distances, and so carrying the extra mass of large packs and carrying the extra cost burden of large batteries is a huge technical and product challenge that I'm not sure is going to be solved easily anytime soon. There are promising other ways to solve those problems with things like fuel cells or hydrogen propulsion. And I think all of those solutions end up still having electric drivetrains, which I think is interesting. I think the internal combustion engine is clearly going to have a much more diminished role in the future of motive transportation.
Yeah, the world is moving on and they're not stopping for us, right? And the technology is moving on. The batteries technology and all the technologies and getting better and cheaper every day.
Absolutely. Yeah, it's a huge difference from when we started Alta Motors. When we started Alta, if you broke down the components of a vehicle that we needed, so high voltage battery, inverter, motor, and really a few other bits of electronics like a BMS, we couldn't really buy any of those things off the shelf. And not to say that there weren't things on the shelf. There were industrial products on the shelf. There were motors that had been produced for other programs, thinking EV1 and other things like that. But there weren't really compelling cutting edge things on the shelf. And it also that Tesla blog and Eberhard that sparked this thing that, hey, this may be possible. But I have some hard fast rules that I try to follow in this world of trying to create EVs and trying to create these products. And the biggest one is that we're not in it to build a product that just can be called electric. I mean, it's not just to build an electric motorcycle. We're here to build better products. We're here to build products that, by virtue of their features and qualities, are better than the products of the past. And I don't really consider electrification one of the features. I consider it's sort of a byproduct of the approach. And so to build a great electric motorcycle or even a great electric car or anything else, you really should be striving to build a better car than the previous vehicles. And so that may mean that you've got to achieve better performance. So in the case of Alta, it was a performance, even a racing motorcycle, and we set out to beat the ICE motorcycles around the track. In the case of a car, you can see now with products from Tesla and Lucid that the cars are almost every way from the equivalent gas or ICE powered vehicle that you can purchase. And I still believe that that's an important thing to strive for and accomplish because the consumer has a lot of choices. And a lot of them are waiting for cost to come down, but they're not willing to trade down. They're not going to go out and buy something that's 30% inferior to what they have. There's really not a compelling reason to do that. We also took on that approach at Damon, and the Damon products were clearly designed to compete head to head with the top of the line products from Italy and Germany that we benchmarked.
Looking back, what's one piece of advice you would give to your younger self starting out in the EV industry?
Well, it's mostly that you can be blindsided by things that you've never experienced or don't know about, and so some of those wise senior folks in the room to give you a little bit of that advice. I guess the other one is that it always takes longer and costs more money than anybody hopes it will, and it's good to know that into it.
Damon Motorcycles was known for its innovative safety features and user experience. Can you elaborate on the key challenges of integrating these technologies into an electric motorcycle?
Yeah. So the safety system that was developed at Damon, largely before I joined the team, consisted of cameras and radars that would, much like an autonomous car these days, would map the surroundings, identify potential threats, the trajectories of vehicles and people, and then alert the rider through both visual and haptic means to these threats. And so, as a developer of the motorcycle, I had to accommodate cameras, radars, haptics, incorporate these visual cues into the dash and display. We had to test their function with, and lots of testing. And it was very interesting. It's interesting to think about that space. I think it's an important part of the business to reduce danger and increase safety in two wheelers, all the way from bicycles through motorcycles. I think that the world would be well served by more people riding bicycles and motorcycles. They take up a lot less space, both when they're being used and when they're not being used. They're a lot less expensive. They're typically use a lot less energy to accelerate and move around. Um, and they're in many ways more convenient for at least for short trips. And so if we can make those things more safe, they'll become more appealing to a broader group, and we'll have more adoption. So it was a little bit challenging to integrate that into all the body work and et cetera, but it was worth it, and it wasn't really that hard in the end.
And most of the world moves on motorcycles.
That's right. I like to remind people every time I get a chance that the world's largest form of motorized personal transportation is a motorcycle globally. We don't think of that as being true in Europe and the United States, but globally it is absolutely true. And I really look forward to participating in the reduction of carbon emissions, just in the U.S. and Europe.
The Alta integrated chassis and battery pack were groundbreaking. What were the key design principles that made them so effective?
Well, the key design principle is one of up integration. And so it's this idea that if you have a collection of parts that do a job, they will be lighter and less expensive if you can make them into fewer parts. Right. So at Alta, we tried to make every part do at least two jobs. Sometimes they did five jobs. And that's kind of true of the way that we created what we refer to as the rear bulkhead of that motorcycle, that incorporated the cooling loops for the motor and the inverter, and was the main structural core of the motorcycle. That did many jobs. And similarly at Damon, where we created what we called Hyperdrive, it's a monocoque stress chassis made out of large die castings that incorporates the majority of the electronics, the power electronics, charging, BMS, DC to DC voltage electronics, as well as the high voltage battery, all into one large structure. It's the main structure of the motorcycle. Similarly, it's doing many jobs. And I didn't invent this idea. This is a kind of you can also see this trend actualized in the large castings that Tesla is now doing in the cars, where they make a large aluminum or magnesium die casting that is a structural element that been a collection of many parts, and now it's done all in one time. I think philosophically it's a great thing. But I will give credit to Britain, who's the developer of the Britain motorcycle. If you're not familiar with it, I suggest you look at it. It's a home-built ICE motorcycle that was in New Zealand in the 90s. John Britton achieved amazing on the racetrack with that, and he very much adhered to this policy of trying to up integrate things and trying to make one multiple jobs.
Electric motorcycles face unique challenges compared to electric cars. What are the most critical technological advances needed to make them more mainstream?
Yes, it is a much, much more design environment than the automobile world, in my opinion. And it is so because you've got so much power and so much capacity in such a small space. So you're trying to pack in all of this stuff into this tiny little space, and you have huge constraints on weight. So, if it's another 50 pounds, no one's going to notice, right? No one's care. If a motorcycle weighs an extra 50 pounds, it actually matters. It affects the dynamic performance of the motorcycle. It affects its acceleration, its braking distances, and it really matters. And in certain categories, there's I'm thinking Alta with the off-road performance racing categories, and motocross categories. You had to be within kilos of to be considered a viable product. So motorcycle space, volume, mass, way more difficult than in the automobile space, in my opinion.
When you were at Damon Motorcycles, what was the hardest problem you had to solve?
I mean, in any startup is keeping the lights on, and having consistent funding, and having the ability to operate every day at the sort of maximum capacity that you need to, not be fearful that that you're going to run out of funds, or you're not going to close the next round, and causes people to either take too big a bets, or to have enough confidence and not be able to bet when they need to, or that's the word, not be able to commit to purchases or hires or maybe even doing the opposite of that, right? Hiring in retrospect when the fund is not consistent. So the hardest thing was the environment and have a consistent level of funding. Yeah.
If you go back in time and change one thing about the development of Damon motorcycles, what would it be?
Oh, I think that Damon, clearly still a going concern. They're listed on the Nasdaq and they're going forward. I'm no longer involved. I think we probably could have saved a little time here and there, and I think that's generally always true in these programs, right? You go down a few dead ends with either suppliers or technical strategies that course on, and so Damon, probably too much innovation, right? That filled with so much innovation. I mean, there's of like 20 or things that Damon did simultaneously and tried to bring to the market all at once. The consumers are very excited about it, and it garnered a lot of consumer deposits. But it broke one of the cardinal rules of startup, and that is you need to really focus and get to the minimum viable product and get to market as fast as you can. And one of the easiest ways to do that is to reduce the number of things you're trying to do simultaneously and stage those things to come on later. So Damon probably took on too much stuff too early, and that's cost time. Yeah,
Can't do all that right in the beginning.
that's right. Yeah.
You mentioned a few differences in design and manufacturing between EVs and motorcycles. Are there any others that you like to mention?
I mean, when you get the realization of what things end up being in comparison, you end up with a lot more stress on thermal systems in a high performance motorcycle because you've constraints, and so you also have cost constraints, and so you're kind of trading, say, smaller high motors with greater cooling needs versus the potential to make a cooled motor. We don't see those in cars much anymore. We definitely did in the beginning, but in the car world, they build motors that are typically just far out oversized for what you need, and they have a high continuous duty that far exceeds what people normally do. On a motorcycle, everything is designed, at least the high performance motorcycle, like Hypersport or like the Alta Motors Redshift, are designed, really the edge of what's possible and what can be achieved, and it creates a lot of stress in cooling systems. A lot of stress in the EV components that you have to mitigate and confirm through testing. You're going to meet the lifetime requirements, et cetera, that the consumer demands.
Shift gears and talk about batteries.
All right.
What are the most exciting developments you're seeing in battery technology?
Well, I'm always excited about capacity increasing. I think we've seen capacity increases slow down in recent years, right? We're not achieving a consistent increase capacity that's the same as it was in the early years of lithium ion batteries. But there's a bunch of other things that are happening that are quite, is that cost has come down. And so the cost has come down significantly. It's literally at a quarter or even a 20% of what it was when we founded Alta Motors, and that's a significant change. And some of the features of the batteries have really improved significantly. So it's now possible to buy batteries that have a really nice balance of power and energy both together. And so it used to be in the early days that you sort of pick power or pick energy, but you never got to have both. And the compromises were not great. So you had to figure out other ways to deploy, say, an energy and get sufficient power out of it by making a larger pack. And now we've got really great balances of power and energy. I'm thinking some of the products from E1 Moly, some of the products from Samsung are quite incredible. But I think the most exciting thing is the ability to do fast charging. And so we've traditional cells, right? There's traditional chemistries, NMC, NCA that now have the ability to charge at 2 and 5C, an incredible charge rate. We're talking potential for sub 20 to quick charge on a battery, and this changes really how you think about the design of these vehicles. In the car world, it means you might not need a 500-mile pack anymore, because you're not trying to have enough pack that you're limiting the exposure of the other consumer to like sitting for the pack to charge. So you up if you've got sufficient charging capacity installed, and that capacity has been increased number of installations globally. You can show up and you that vehicle fast now, but much faster in the future with these new cell chemistries. And in the motorcycle space, where the packs are typically much smaller, the packs could be 1/5, 1/10 the size, even 1/20th the size of a big automobile pack. You don't need nearly as much power to do this fast charging. So the electrical infrastructure demands are much lower. So you can imagine scenarios where if you've got sufficient charging infrastructure installed, that you can 95% of all your two-wheeler trips on a smaller pack that costs less money to produce, and it was really convenient to fill up, something like going to the gas station, at all. And I think that's going to have a big impact over time on the products that we see and the consumer acceptance, because truly even when we started Alta was cost. And the biggest problem today is still cost. We're seeing, especially in China, some vehicles made that have cost that are equivalent to the gas-powered car. We're not quite seeing that in yet. We're certainly not seeing it in the Europe and US in the motorcycle space. But these technologies like higher and fast charging and lower cost cells are going to help us achieve those things.
I was talking to a battery expert a couple of days ago, and they expect prices to keep coming down. So that
Yeah, there's probably a bottom to it. You can look at that go into it and do a sort of bottoms up analysis of that. And there's a point where without a incredible technological change, we're gonna hit that asymptotic part of the curve and prices stabilize. Though there are new, in addition to the ones we just spoke about that I find interesting. The other one is solid state batteries or a solid electrolyte battery that also pretends to have faster charge rates. There's a lot of capacity being installed right now for batteries like that. It's not clear to me that they'll have wide adoption in all forms of electrified transportation. I'm not sure they'll work well with motorcycles. At least the formats that they make to work well in cars might not translate really well to work in motorcycles, because they might not be too big, etc. But that solid state battery solves one of the other challenging design issues around high voltage lithium ion batteries. That's safety. And safety is a really important topic to create high voltage packs that are fire safe or propagation resistant, so thermal propagation resistant. And that's the idea that if one or a small group of cells is damaged enough or has a manufacturing defect or some other, doesn't just matters that these happen statistically. So if there's a defect in a battery and that battery vents, we see very high temperatures locally in that cell. And if you don't safeguard against those temperatures transitioning to adjacent cells, right? So that temperature can bring adjacent cells and elevate their temperatures. And if those adjacent cells' temperature is elevated beyond a certain point, they will also go into this thermal runaway or venting scenario. And you can see that propagate through an entire pack. There's been pretty accounting fires that have happened, and going Tesla and Martin Eberhard. One of the things that in the team at Tesla, and I was very fortunate to have Martin as a investor and advisor at Alta Motors, and he would come and do design reviews with us. He instilled this same ethos at Alta of battery safety. I brought that same ethos to Damon, that you must design battery packs that are propagation resistant, right? You don't want that risk. You want to contain that risk and create packs that can tolerate some amount of abuse and cells venting without that propagating throughout the pack. It makes clearly a safer pack. Now, solid state cells portend to sort of fixed cells no longer vent. The electrolyte is captured in this solid mass. We don't have the same volatility, and that could make battery packs much safer in that aspect, and that's also very exciting to me because I think it's important that we, products and that they don't have any qualms about bringing them into their homes and apartment buildings, etc.
So beyond energy density, what other factors are crucial for widespread adoption of advanced batteries?
I
You
mean,
you
it
mentioned,
it's cost, it's everything else, right? It's
yeah, and it's so important for vast mass adoption and the industry as a whole.
Yeah, and we're for instance in New York City, they've seen a really great uptick in the use of electric delivery bicycles and scooters and small vehicles. They've become very common in New York City. But they've also seen an increase in battery fires from these low cost and frequently inferiorly designed and developed that are, mostly have been unregulated. And so in New York City, they've required the UL battery safety standard on all vehicles sold and used within New York City, and hopefully that will be enough that over time it will curtail the number of fires that they've been seeing from those vehicles, which I think is around 50 a year. So it's a significant issue that they're trying to, through the adoption of this UL regulation, get under control.
They have a free exchange program for those delivery people who are using those cheaper, older batteries, scooters that were not UL certified.
Yeah.
Who's doing the most to accelerate innovation and collaboration?
Well, gosh, I'm not sure that I say. I know that I have had the pleasure of working with some really wonderful, famous companies that have included Panasonic and Samsung and LG Chem, and these are incredible companies. I think some of the best battery companies in the world. Not so much because they have at any one time the technology. There are frequently smaller scale, or innovation happening and that are very interesting. Companies have done of something that's very in our, and that is that they've created very high quality products. Then they've created the systems to manufacture those very high quality products very consistently. And so you have very high quality that is duplicated over and over and over again, and very low cost because the level of automation and control that they have. And so I like working with those big companies that have those controls. And I'll put E1 Moly in there. They're much smaller, but they're kind of an example of a little more innovative company, and that they've focused on delivering a lot of power and agents package, and they're going after motorsports, etc. And they've done a really good job of that. But those big guys are kind of the key to more mass adoption of EVs, in my opinion.
What are some of the biggest hurdles the battery industry will need to overcome in the next 5 years?
Well, I think they're doing it. I mean, they currently have too much, and they've they even the capacity much inventory, which is a not a bad the uh, manufacturers of EVs, and because they now suddenly have a lot more choice and the costs have come down over time. These things need to be stabilized, so we need to stabilize the supply of the raw materials. I would guess that we develop more of the raw material resources globally, more different supply chains, so we're not relying on just China, especially for some of the not only the raw, but some of the components, highly technical processes to develop cathode anode materials and whatnot is dominant in. We need more so that it's more competitive and we're less prone to kind of OPEC style unilateral price changes. So
More countries are getting into mining, and trillions of dollars are being invested in mining
yeah,
in new countries, new places.
yeah,
Like,
absolutely, and it's required. And we need to. We're not transportation system that we built over the last 120 years to run on fossil fuel into running on electricity overnight. And so there's a lot of conversion of minerals into products that we can incorporate into these vehicles that need to happen. We need to develop these new resources, these new programs to do that. It's a humongous undertaking, not to mention the updates to the electrical grid, installation of more charging infrastructure.
what are your thoughts on recycling and the second life of EV batteries?
I'm really excited about the space. It's interesting. You see every then these diatribes where people talk about the amount of energy it mine lithium and creates the components in an EV, and how it's that has an environmental, has a carbon footprint, and that's all absolutely true. Though when you add to that we can reuse certain numbers of the batteries that no longer meet the requirements of, say, an automobile. Now we've got standardized that you would see in the cars that can be redeployed. A hope is that there's more design consideration taken over time so that those can be redeployed. We can quickly understand the state of health of those, and they can be redeployed. And I think that's a business opportunity that people are working on. But probably even more important than the reuse is just the recycling. And so I can think of a number of companies, say like Redwood Materials, who are installing to buy defunct packs and then to ostensibly extract all of the resources and materials from those in a series of refining processes. And I've read of figures as high as 90% recovery of all of the valuable materials from doing this, and that over time that could represent 20, 30, 40% of the entire supply chain of materials going into building batteries. That's a pretty exciting thing to me. So we create that loop where we're not having to earn it completely on the new resources. We can add to this. Now that stuff's not going, it's getting reused. It's a virtuous cycle,
Yes, claiming 95, 99%.
which absolutely incredible. Yeah.
What's your vision of the future of electric mobility beyond motorcycles and cars? Are there other modes of transportation that you see being electrified?
Well, literally every mode which that I believe will be electrified, right? So, we talked about the challenges of the, large trucking and transportation, but I think those challenges over time, they get solved and that gap gets smaller and smaller. I think that being here in California in the Silicon Valley, there's a lot of effort going into vertical takeoff and landing personal aircraft that will be used as taxis and et cetera, eventually even running autonomously. I think that's another really interesting space, living in a place with a congestion. It's freeing to imagine hop in some clean vehicle that would ride over the top of that congestion and get you to your destination quickly and easily. I think is another one, probably still many years away from dramatically reducing the carbon footprint of, but it's one that we're going to have to, right? We're going to all probably have to take less trips because of the carbon footprint is just astronomical flying in aircraft. But time we figure out ways to reduce that carbon footprint and make that something that we're not ashamed to scale.
Yeah, people are working on ferries and
Oh yeah, yeah, yeah. There's I've read the ferries in Seattle. They're getting close to deploying them, and some in up in BC, in Canada. And so yeah, that's another great use, right? You can install those things, and the weight penalty is not big of a deal, and you can put some really big batteries in there, and yeah. Makes tons of sense, and then people aren't breathing the diesel. It's quiet. It's a much experience.
yeah, they're doing it in Oslo and between Uruguay and Argentina because they has almost 100% renewable and solar and biomass. So they charge it with renewable energy and the ferry will go between Uruguay and Argentina. It's all electric. How
That's
cool is
great.
that?
We need more of that. Yeah.
What are the biggest obstacles that are the wider adoption of EVs?
Back to cost. I think we're still a little expensive on EV, so it means that the parts of the market that you can develop products for are on that sort of higher end premium side. Though there's light at the end of the tunnel. We're seeing, for instance, in China, where we've got automobiles now that are got real packs. They're for super high distances, but they're coming in at pretty affordable prices, and they're competing head to head with the gas equivalents, and with a little bit of government a better option. The total cost of ownership of EVs is still a really great deal. The cost to power them in most places is still far less expensive than putting petroleum in your tank. But a lot of people don't really have a choice. They have to go with the lowest cost option, and we've got to get EVs to a place where either people are willing to pay a little more in exchange for that lower cost daily operation, or we meet the equivalent price. So cost.
Yeah. So in Kenya, I think they use motorcycles where they take the battery out and take it up stairs to their apartment and
Yeah,
charge it and
yeah,
put it back in. And the cost differential is like 1 to 8, 9, 10 in some of these developing countries between
absolutely.
fuel and electricity.
That's
Even in
right.
some countries with expensive electricity, it's still 1:8 ratio. So
Yeah,
it's a no-brainer for cost of ownership
that's right.
and maintenance.
Yeah. Yeah. Maintenance is incredible, right? There's virtually nothing that you touch besides in final drive, brakes. It's like everything else is virtually don't have to the life of the vehicle.
Right. I used to joke with people that my only maintenance, my electric EV, is windshield wiper fluid
Yeah.
and tire rotation. What advice would you give to aspiring entrepreneurs and innovators looking to make a difference in the EV industry?
I think it all starts with the product and the product definition. I'm a technologist, and I love down into the weeds and solve these problems. I've got over 25 patents with my name on them. But it's clear that the consumer buys the features of the product are really the most important thing. So you've got to verse yourself in what's needed. And the EVs, a lot of them can be solved in a slightly different way than they were solved previously, and even the product definitions are different. So you have to understand what people do with vehicles, right? Because in a lot of ways, we've adapted to what the ICE vehicles do well, but it's not necessarily what we need, or it's not the minimum thing that we need. It's just what they do well. So we've gotten used to that. And so in the EV world, we really need to understand what the consumer wants, what they're excited about, what features that they want, and it may mean Tesla's done, where you add a lot of additional technology to the vehicle. We did this at Damon as well, where you assume you've got now likely grown up a smartphone, expect things to behave in a really intelligent, predictable way, smooth. They expect a lot of software features that are intuitive, and this is not what your ICE motorcycle looked like, right? And so we've got these like electronics driven vehicles, right? Multiple microcontrollers in them, multiple computers, and there's a lot of software defined product in a lot of ways. So you've got to get versed in that world and that language, and you have to translate that into products that and features of products.
What emerging technologies outside of batteries do you believe will have the biggest impact on the future of EVs?
Oh, wow. I think there's tons of to innovate the constraints of the EV drive. So we're looking at higher voltage. You're looking at silicon carbide in the electronics. You're looking at integrating more and more up integration of the electronics, potentially combining charging with inverters, going to higher and higher frequency switching, driving more efficiency out of things, driving lower cost. And it's back to cost, right? It's not about getting more power. We've already got vehicles that are far more powerful than we, quote unquote, need. It really is end up being, can you build these things at scale, at cost, that bring more people into the world of these vehicles, right? There's always some people with enough disposable income to buy anything, but the real trick is to, how do you the EV car world is getting there, right? The growth rates are still really strong, and I think 45% of all new China that are sold are EVs.
It's over.
It's over 50. That's incredible. Part of that is the way that the government acts within that system, incentivizations at, the manufacturing level or level. We've seen some good Europe. US is lagging behind in that way. Motorcycle is lagging behind too. So we need some better products in motorcycle, and we need some government that really helps.
Yeah, India has gotten 500,000 electric twin three-wheeler in the last year.
It's incredible. I had the pleasure of a few of those plants in India, and meeting some of the folks involved, and it's incredible to see the scale that's rolling out in and the product that's happening there.
Did you guys have heads-up display in the
Interestingly enough, one of the co-founders of Damon, who's the current CEO, Dom Kwong, he had previously been part of a called Recon Instruments, and they built heads-up displays. And so he had a lot of experience with it, and him and Jay Giroux, who was the CEO for many years at Damon and the co-founder, they decided that heads-up displays would be distracting for riders, and they were not bullish on the future of heads-up displays in motorcycles. I personally haven't. I've never ridden with one. We had Scully helmets heads-up display years ago, and I fitted that helmet, but I didn't ride to see what it would look like. Jury's out for me, but it's a space that's it's ripe for innovation and exploration.
you think of Donut Labs new engine?
I don't know that one.
Okay. Okay. They have some innovations. What about difference between Lucid and other EVs?
I think Lucid has done a really good job of, they've got a really great drive, got really good performance out of their motor and inverter. I think their product is very high performance. I think they're figuring out to get some scale to that company though, and they're at, they're somewhere for.
Want to be the Intel Insight for EVs?
We'll see. I mean, that I've heard things times in my career, and there's other companies trying to do things that are traditional tier one suppliers in the EV or in the ICE world. We'll see what happens.
What is one thing that gives you the most hope about the future of clean energy?
I mean, the fact that people love these the amount of excitement that we got around the Alta when we released that, and all of that would they would decide and tell how much fun they were having bike and all the new things they could do because it was quiet and how enjoyable it was. If they were riding more, I think that the opportunity to make wonderful products that excite people is still very strong in the EV world. So I'm excited about reducing carbon, putting smiles on people's faces at the same time.
Anything that we haven't covered that you like to mention?
Gosh, not offhand. It's been a fun chat.
Well, thank you so much for your insights. Please keep watching Clean Titans for more exclusive and insightful interviews from the clean world. Please subscribe, like, share, ask questions and comments, and try to get you answers. Until next time, stay charged.
Thank you.